This section is about basic classification. So we are going to look at what is classification. There are three sections that I will explain. First, I will explain about the concept, what is classification, and we are going to look how to improve the performance of classification, and then at the end we are going to look at the model comparison and how to interpret the result. So you can refer to the Google Colab. This is the Google Colab for the classification. As we learned last week, we are now in the machine learning section on the data science. The machine learning is one of the important part, and we are still doing the supervised learning. The supervised learning means we use labeled data to train the model for prediction. If you still remember this table, you can see that if we are dealing with the supervised learning, and if the label is numerical, then we can use regression. Okay. So there are some regression techniques. For example, the linear regression, we learn about the KNN regressor and etc. So those things we can apply to the numerical label data. Now, today we are going to focus on the categorical label data. So if the label is categorical data, we call this is classification. So what is classification? We will learn today. In the classification, we call the label is categorical. For example, if you still remember the data of iris dataset. Okay. So this flower, Iris versicolor, Iris setosa, Iris virginica. So how can we classify the data? In the iris dataset, we have the feature. Okay, those features: sepal length, sepal width, petal length, petal width. And I know that this is the measure for the sepal length. In this case, this is in centimeter. So if the sepal length is 5.1 centimeter, if the sepal width is 3.5 centimeter, if the petal length is 1.4 centimeter, and if the petal width is 0.2 centimeter, then the flower is setosa. Because this data is categorical, okay, and if we want to use this data as the label, we call this is the task for classification. And this classification, you can have the numerical data as the features. The other data set that we already learned is the golf data set. In the golf data set, you know there are categorical features. So for example, we learn about the outlook. The outlook, if it is rainy or sunny or overcast. And the temperature, whether the temperature is hot or mild or cold. The humidity, whether it is high or normal. Windy, whether it is windy, true, or not windy, false. And the decision, we want to know whether the person, so this is the person number 0, this is the person number 1, this is the person number 2, and so on. So the person number 0, the decision is no. The person number 1, the decision is no. The person number 2, the decision is yes. Then we can look at the data. The data is categorical. Once we have this data, we can predict or we can know the decision from every person. And the label is categorical. So the categorical data here is we have yes and no. In the classification, we can say it is the discretization of the target attribute. Do you know the meaning by discretization? Discretization, it means if we have numbers, let's say I have number 18, 20, 25, 40, 45, 46, for example, like this one. This is numerical. So I can do the discrete. So I want to make category. For example, okay, this number, maybe this belongs to young age. This number belong another category, for example, adult. Then we want to discretize. So that's the meaning by discretize. When you have the attribute with numbers, yeah, you can discretize. Last time we learned some discretize techniques. Now, I do not want to teach you how to discretize, but the discretization, when you want to make categories, there are several kind of categories. The first category is the binary classification. Binary, it means the numbers or the data that we have, we will make it into two categories. When the target attributes contain only two values. For example, the play golf. The play golf, you have only two values, yes or no. So the type of classification will be binary. Let's say if you have another kind of data, credit risk, high and low, then yeah, because the data contains only two options, high or low, then this is also a binary classification. We have another kind of classification. We call it multi-class classification. For the multi-class classification, it means the target attributes contain more than two values. For example, the iris dataset, it is a multi-class classification because there are three classes. We have three kind of flowers: Setosa, versicolor, virginica. In the other kind of data, let's say if you want to learn about the sentiment analysis in the text analysis. In the text analysis, we have the sentiment analysis, and we can classify the words into three classes: positive, neutral, negative. So we call this is also a multi-class classification because the values, there are more than two. And the other kind of classification, I can just say that it is a non-standard classification. So the non-standard classification, for example, semi-supervised. Semi. Semi means some of the data might not be supervised. Some of the data might be supervised. Multiple instance learning. We call it multiple instance. Multiple means many. We want to learn from many instances, not only one instance, but we want to learn from many instances. Or there can be also another kind of learning, for example, multi-level learning. So there, in one data, there might be y1, y2, y3. So in one data, you can have label 1, label 2, label 3. So this is the non-standard classification, and if you have interest on this part, you can learn later. Okay. Now let's look at the example. You learn about the data set from golf. So this is the golf data set. The classification, it is a concept to predict the categorical values. So I have this data. The outlook is rainy, the temperature is hot, the humidity is high, the wind is false. Okay, the person do not play golf. The second person, rainy, hot, high, true, the person do not play golf. I have this data. Now, let's suppose I have a new data. So this is the training data, okay. And yeah, I can do something splitting this training and the testing. And then after I build the model, I want to predict. If now the condition is sunny and the temperature is cool and the humidity is normal and the windy is false, what is your prediction? Is the person will play golf? Yes or no? So if you look at the data, maybe you can look sunny. Okay, maybe this one sunny, this one sunny, cool. Okay, they are cool. And then normal. Okay. And false. Oh, there is one example that the decision is yes. Then I can say maybe this person also will play golf. Okay. Now the problem is, if the data is small like this one, it is easy. But what about if the data is huge? If the data, there are 1,000 data, so it is not easy to look the data one by one. And there might be another kind of classification. So as I mentioned before, we have the semi-supervised. What is semi-supervised? Semi. We call it semi. It means some data are unlabeled. So maybe if you have the data like this one, and some data like this one have no label, have no label, have no label, have no label. Then you need to do something first in order to make a good classification. So this is a kind of classification that you can learn. And now there are also another kind of variant for the classification. For example, as I mentioned before, it is not about the golf data set, but it is about the multiple instance learning. So do you know zebra? Zebra or mal? So if you look at this kind of picture, you know that this is zebra. This is orokmal. What about this? You can see that it is not zebra. But if you look at this section, the pattern of the skin, the pattern of the skin, they are similar. Okay. So if I look only on the pattern like this one, then it means I can figure out that this is zebra. However, if I look into this mouth or if I look into the face, then this is not zebra. Another thing, I can use this instance. So this is another instance or another kind of example. This pattern, if you look at this pattern is belonging to zebra. But actually, if you look at the overall picture, this is not zebra. So we want to learn from different instances. What about this? If you look at this section, okay, if you look at only this section, or if you look at this section where the section contains some white and black, or some white and chocolate, so we can say that this might be zebra if we look only in this section. But from the overall, we can say this is not zebra, this is hay. Then, in order to make the classification, so we collect many instances, and from those many instances, we can predict whether when I have this picture or when I have only this section, I can predict whether it is zebra or not. So this is also the same. If I want to say that this is zebra, then in one picture, I can have many kind of section. So the section of head, the section of the tail, the section of the pediphill, or the section of the cloud. When I look also in this case, yeah, this is the body, this is face, this is the grass. So if I have those section, then I can figure out whether this is zebra or not based on the pattern. So we have the instance 1, we have the instance 2, we have the instance 3, and we have the instance 4. And in classification, we have also another kind of variant. We call it the multiple label. So in one image, we can have several labels. We can see there are trees, and we can see there is one elephant, and we can see there are lion. Then this is Y1, this is Y2, this is Y3. In one picture, there are many labels. In this image, then we can do the prediction. The person is on the beach and the person is still doing survey. Okay. So the labels is one about the view of this picture, and the other is about the person, about the activity of the person. If we are dealing with the multiple instance, multiple label learning, then it is more complicated. So in one image, we can split the data. So this data is one instance. This data is another instance. This data is another instance. And this data is another instance. This section is another instance. This section is another instance. Once we have many instances, then I want to make the label. Okay, the instance 1 contain 3. The instance 2 and instance 3. Yeah. For example, the instance 2 contain elephant. The instance 5 contain lion. But the other instance, there is no label. The same with this image. I can also make it as the multiple instance and multi-label. For example, in one image, I have many sections. Okay, this is the first section, and I want to make it, this is the first instance. This is the second instance. This is the third instance. This is fourth instance, and this is the fifth instance. If you look at this one, the instance 1, it is not indicating anything, but the instance 2, instance 4, instance 5 indicating bits. The instance 3 and instance 5 indicating this is perfect. So those kind of things, yeah, you can do with classification. There are many kind of problems in classification, non-standard classification, especially in the image. Now let's get back to the data that we have before. As you know from the regression, we learned that whenever we have the data, we want to make the model. And in order to make the model, we need to put only on the training set. So the data that we have, let's create the model, and then we create the model from the training set, and we are going to measure the performance of the training set into the testing set. Now let's suppose this is the training set and this is the testing set. Before we go into the details of the classification, let's learn about the performance metric. The performance metric, in this case, we are going to look on the details about the confusion matrix. So what is confusion matrix? We call it confusion. So it is a kind of table, that visualize the performance of a classification model, showing how many predictions were correct and incorrect. So how many predictions are correct and incorrect for every class. So here you can see the actual. It means this is the data that we have. Predicted. This is the result from the model that we created. We have, suppose, a binary classification. Do you know what is binary? Binary means two class. So in the binary, we have yes and no. Or in the concept of the classification, we call it positive and negative. In the predicted, of course, because there are two classes, yes and no, then we will have the prediction, which is also yes and no. In the binary classification, we call true positive if the actual data is yes and the prediction result is also yes. We have the actual is yes and the predicted is no. So we call this is false negative. We have false positive. It means the actual is no and the predicted is yes. We have the actual is no and the predicted is no. Then we call this is true negative. Okay, we have those four aspects in the confusion matrix. For every of this, there is a formula. So for the binary classification, the analysis, there are two kinds of analysis. This is the common analysis. First, we want to check the high test accuracy. If the test accuracy is high, then it means the generated model can predict correctly on the testing set. High training accuracy. It means the generated model can predict correctly on the training set. We have the testing set and we have the training set. Now, if you look at the details of the formula, we have the word accuracy. So accuracy means TP. What is TP? Here you can see TP. It is the true positive plus TN. Tn is true negative, divided by Tp plus Tn plus Fp, Fp is this one, and plus Tn. Sorry, this is not Tn, this is Fn. Why I missed this one? This is Fn. Okay, one more time. The accuracy means the total of the true divided by the total data. Then it means the Tp plus Tn divided by the Tp plus Tn plus Fp plus Fn. And we have another kind of matrix we call recall, or sometimes in the literature they call it sensitivity. So the formula will be Tp divided by Tp plus Fn. So Tp divided by Tp plus Fn. We have the specificity. Specificity means the Tn, or the true negative, divided by Fp plus Tn. Okay, Fp plus Tn. So we want to know the proportion of the true negative compared to the actual no. Okay. Now we have precision. In the precision, it means I want to know the correct prediction, which is the true positive, compared to the Tp plus Fp, comparing to the result from the prediction, which is yes. And the last one is negative predictive value. I want to know the Tn, which is the true negative, divided by the Fn plus the Tn. Fn plus Tn. Now let's see if I have, oh, sorry, I have another kind of measures also for the classification. So in this case, I'm still doing for the binary classification. For the binary classification, I have another measure, we call it F1. Or sometimes you will write F1 score. Okay. So it is a model's performance by calculating the harmonic mean. So the harmonic mean means I want to make it balance between precision and recall. So it is to find the balance between precision and recall. It is a good measure when the label is imbalanced. The label is imbalanced. It means if you are doing the data set with the golf, so we have yes and no. Let's say I have 20 data. So among the 20 data, there are 11 yes and there are 9 no. Okay, then we can say this is still okay, or the data is balanced. But let's say I have yes or no, and let's say I have 100 data, and the number of yes, there are 95 data, and the data which is no, we have only 5 data. Then we call this is imbalance. The data is not balanced. The number of data of yes and no, there is a big gap. Okay, so imbalance. The number of label data for each class is highly different. Because the data here, yes, is 95, the data in no is 5, then it is imbalanced. If the data is imbalanced, we need to use F1 in order to check the correctness. This is the precision. and the correctness of the prediction based on the actual data, which is the recall. And then we will divide with the precision plus recall. So this is good for the imbalanced data, because when you have the imbalanced data, it is not good to use the accuracy because there might be some bias. So the F1 score, we can see something like weight, like this one. The precision and the recall should be in balance. If the recall and the precision, they are almost similar values, okay, then there is no big difference between the precision and the recall. But if the precision and recall it is highly different, then it means we have the value later. If it is high, okay, this is good, but if it is low, this is bad. There is another kind of measures, we call it MCC, or Matthews Correlation Coefficient. So this MCC, it is a performance metric that measures the quality of binary or two-class classification model. So using this MCC, it is usually for the binary classification. But yeah, we can also use for multi-class classification. Later, we will learn more about the multi-class classification. So the formula, you can look at this one, TP. As I mentioned to you before, TP is true positive. TP is true positive. And TN is true negative. FP is false positive. And FN is false negative. Okay. Then yeah, we can do the calculation using this formula. The result of the MCC will be in between -1 and 1. So some of the literatures, they already put a kind of standard. If the value is in between -1 and 0, then we call this is the inverse prediction, or the prediction is toward in the different. So for example, if the MCC is -0.5, then the model actually, if you are predicting 1, actually this is not 1, this is the inverse, or they are actually predicting 0. So the correctness is very low. Quick prediction in between 0 and 0.3. 0.3 and 0.7, it is moderate prediction. And after 0.7 until 1, it is strong prediction. If the value is 0, then it is a random prediction. It means, yeah, 50-50. 50% yes, 50% no. For the multi-class classification, we can use the macro averaging and micro averaging. So I will not explain in detail, but later in Python, we can just type the parameter and we can change the parameter. So macro averaging means we are going to calculate the MCC for each class individually, then average the result. So if we have the class 0, class 1, class 2, so we are going to calculate the MCC for class 0. We are going to calculate the MCC for class 1, and we are going to calculate the MCC for class 2, and then do the average. Or if we want to do with the micro averaging, means we are going to calculate the overall TP, TN, FP, and FN. So we can make the confusion matrix. We get the TP, we get the TN, we get the FP, we can get the FN, and then after we had the overall TP, TN, FP, FN across all classes, then compute the MCC. So it means this is similar to the binary classification. Now let's see with we have this data. We have the data from the golf dataset. Yeah, I will explain later about how we can get this one. 0, 1, 0, 1, 1, 0. Do you still remember? When we have the data outlook, there are 3 kind of data: sunny, rainy, and overcast. We cannot use categorical data, so we need to use numerical data. Last time we learned about the one-hot encoding. So this is the result from the one-hot encoding. The one-hot encoding here, the outlook rainy is 0. The outlook sunny is 1. Okay, then actually this data has the data about sunny. Temperature hot, mild. So mild is 1, hot is 0. Then it means the data actually is 1 for mild. And the humidity normal is 1. Then it is normal, not high. If the humidity normal is 0, then it means the humidity is high. Windy is true. If it is 0, then it means false. If it is 1, it is true. So you can refer from the data set here. Okay. So you can have this one. If you look at this data set, yeah, this is the result from the one-hot encoding. And we have the actual data. What is the actual data? This is the data from our data set here, and we have the result, whether they are playing color or not, yes or no. Then we have the actual data. This person with this condition, actually the person is playing color. This person is playing color. This person do not play color. So this is yes, this is yes, this is no. Now the predicted. The predicted means if I have a model and I'm going to predict whether the person will play golf or not. Based on the model, the result is 1. Then, okay, the actual is yes, and the predicted is yes. Based on the model, the predicted for the second data set, it is 0. So the actual is yes, but the predicted is no. From the model, the prediction shows that the result is 1. Yes. The actual is no, but the prediction is yes. So we can put into the confusion matrix. When the actual is positive, when the actual is 1, and the prediction is 1. Okay, we have 1 data. When the data is 1 for the actual and the predicted is 0. When the actual is yes and the predicted is no. Okay, we have one data. When the actual is no, when the actual is no, and the predicted is 1, the predicted is yes, then we have one data. So for every this one, we have 1, 1, and 1. Then we have the accuracy. The accuracy means 1 from here, which is the true positive, plus 0, which is the true negative, divided by all the data, 1 plus 1 plus 1 plus 0. Then the accuracy is 1 over 3 or 0.33 something. Okay. What about the precision? The precision is from here. We have the positive is 1 and the true positive, we have also the false positive. Then we have 1 for the true positive plus 1, which is the false positive. So 1 plus 1. Then the precision is 1 over 2 or 0.5. For the recall, this is also the same. We have 1, which is from the true positive, divided by 1 true positive plus false negative. This one. Then the result is 1 over 2 or 0.5. This is the result from the testing set. Now, let's make it more complicated. We can also check the classification result from the training set. So I have the model from the training data and I want to apply to the data in the training set. And this is the result. The actual is 1. The predicted is 1. Okay, we check. Okay, there are 7. How we can get 7? So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So the actual is 1 and the predicted is 1. Then there are 7. What about the actual is yes or 1, but the predicted is no. So 1 and 0. Is there any 1 and 0? Nothing. Now we check on the actual when it is negative or 0, but the prediction is yes. We have when the actual is 0, but the result of the prediction is 1. Is 1, 2, and 3. So there are 3. And the last one, we want to check whether the actual no and the predicted is no. So we have 1. So we have 1 data. Then we can calculate. For the accuracy, it means 7 from the thought true positive plus Tn, this is the true negative, divided by all the data. 7 plus 1 plus 3 plus 0. So the result is 8 divided by 11. For the precision, so 7 divided by 7 plus 3. So 7 divided by 10. And the recall is 7 and 0. So 7 divided by 7 plus 0. The result is 1. Okay. Now let's see how we can do it in the Python, and we are using the KNN. So the KNN, as you know, previously we need to decide how many neighbors. So I'm calling the library KNN, and let's say I'm using the n equals to 3. And I'm feeding the training and the x and the training and the y in the training. So I can use the performance indicators such as the accuracy score. I can also apply the confusion matrix in the Python, and I can get the precision, recall, F1, and Matthew correlation coefficient. Okay, so let's see the Python code. Ooh. Mhm. Okay, first we need to import all the libraries. In this case, I'm using Pandas, NumPy, Matplotlib, and Seaborn. And let's suppose I'm using the GitHub data. So in this case, this is the golf dataset, and this is the data. So we have the outlook, temperature, humidity, windy, and bill golf. As I mentioned to you, for the data, because it is categorical data, so we need to use the one-hot encoding. We transform the data from categorical into numerical. So we have 1, 0, 1, 0, 1, 0. And we select what is the X and what is the Y. In this case, we are looking at the X as the other attributes and Y is the play golf. So this is the X and this is the Y. X means the attributes that we are going to use to predict the Y or the decision. So you can do the splitting. In this case, we are splitting 80-20, and you can check the data. After we do the classification, we can do the prediction, and we can check the accuracy, which is 0.33. And this is the confusion matrix. This is the result from the accuracy, precision, recall, and F1 score along with the MCC. Okay, due to the time, I will continue the next section on Wednesday. Okay. Thank you very much for your attendance. We will meet on Wednesday. Suasana.